Alright, so in this video, I'm going to be showing you guys how to calculate the combined sample variance. So the reason why I'm making this video is because I did not know how to do it, and I looked online on YouTube and somehow nothing came up, and even ChatGPT was spiraling. So first off, we need the variance formula. So the formula is going to be the sum of xi minus the mean squared over n, which is the total number of elements in our data set or sample, minus 1. But since these type of questions, they are going to limit the information given, we're going to be using the computing formula, which is as such, is just going to be the sum of x squared minus the sum of x squared, make sure you have the brackets, over n, and all that will be over n minus 1. Alright, so let's get into an example. So say we have sample 1 and sample 2. Now usually they will give you a minimum of 3 information. 3 pieces of information, which is all you need to solve this problem. First off, they'll give you the size of the data. So let's say for n1 we're gonna have, for sample 1 we'll have a size of 10, and for 2 will be 8. Alright, then they'll be giving you the mean. So let's do the mean of 1 will be 3.2 and mean of 2 will be 3.5. Alright, and then last they'll give you the variance for both, because that's what we want to combine. Alright, so let's just put it at 0.2 and then 0.4. Now the first step we need to do is establish this element right here. It's the easiest one to do too. So to get the sum of x, let's do x1 first. Really all you need is the number of elements times the mean. So for the first one we're going to have 10, I'll just write it out. We're going to have n1 times the mean 1, which is going to be 10 times 3.2, which is going to be 32. And now for our second one, we're going to be having n2 times x2, which is going to give us 8 times 3.5, and which is just going to be 28. Our next step, which is a bit trickier, is we're now going to have to calculate the sum of x squared. So first off, let's go back to our formula here. Let me just copy this. So from our formula here, what we can do is do a little bit of algebra and manipulate our equation here. So let's say this is going to be x1, all right? So we do know that the variance S1 is actually equal to, right here, 0.2. So we can set this as 0.2. Now all we have to do is get rid of our denominator, and to do so we're going to times it by n minus 1. So for n1 we do have our unknown here. Let me write it down here. We have our unknown, which is the sum of x squared minus, we have this already, we just calculated it, which means that we get 32 squared, and that would be over n, which is 10, n1, sorry. And all that will be over n minus 1, or 9. Alright? So now to get rid of this denominator, we can just times it on the other side. That will equalize it. So now let's do that. 0.2 equals x squared minus 32 squared over 10. And so make sure you add your times 9 here. Alright, now we can shift it to one side, and so we're just going to rewrite it as such. We're going to write 9 times 0.2 equals 32 squared over 10. Wow, sorry about that. I'm plus 32 squared over 10 equals the sum of x squared. So let's add a 1 here. Let's just plug that in the calculator. So we get 9 times 0.2 plus 32 squared over 10. Now we get 104. So we can go and say that x squared 1, the sum of x squared 1 is just going to be 104.2. Alright, so the fastest shortcut we can see here is that for, let's say for our next one, x squared 2, well, what we know is that we are going to have our s, our variance of the sample 2, times n minus 1 plus the sum of x2 squared over n. And let's make sure we put 2 everywhere. Alright, so basically what we're just going to get here is going back to our data set, or the information given. We have 0.4 for the variance. So this will be times, and so the sample size of sample 2 is 8. So you would get times 7. And then plus, we just calculated the sum of x2, which is, where is that? Which is 28. So we get 28 squared. And then over n2, which is 8. So we're just going to get, let's put it in the calculator again. And for that, we get 0.4 times 7 plus 28 squared for 8. Okay, and so for that we get 100.8, sorry. Alright, now we basically have all our elements that we need, and we can go ahead and calculate our combined sample variance. So we're just going to denote this by sample variance 1 and 2. So we will have the formula as such is the same thing, just with the combined everything. So we'll have the sum of x squared of sample 1 and 2 minus the sum of x 1, 2 squared over n 1, 2 of, and over all that over the size of our 2 samples minus 1. Alright, so we can start replacing. So we do know that x squared 1, 2 is just going to be equal to our sum of x1 squared plus our sum of x2 squared, which is just going to be 104 point 2, sorry, plus 100.8. Which is going to give us 205. Alright, so then next what we need is our sum of x of sample 1 and 2. This we have already calculated, which is just 32 plus 28, which equals 60. Alright, and last but not least, we're going to have the total size of the elements, which is, we already know it's 10 plus 8, so we get 18. So we can plug this all into our formula. So, what did I do there? So the variance of our combined samples 1 and 2 is going to be 205 minus 60 squared over 18, all of that over 17, because it's n12 minus 1. Now let's plug that into the calculator. So we get 205 minus 60 squared over 18 over 17. So we get approximately 0.294. And that is all.